So we're on zinc plus cobalt-2 nitrate. We just did zinc with copper. There's definitely reaction there. How about here? Do you expect reaction?
Yes.
Let's see what happens. All right, this one, actually don't see much reaction happening just yet. Maybe this one's a slow reaction. And so let me set this aside here. Although it looks like the color is fading. Do you see that?
Yeah.
But let me set it aside and see. We'll come back to that one in a minute. See if we can see evidence of reaction. Okay, after that, what do we have?
The last one is zinc and silver nitrate.
Zinc and silver nitrate. Some zinc and silver nitrate. And what do you expect for this one?
You can expect that silver salt will form zinc ion.
Yeah, so what do you think it's going to look like? Silver solid? Well, let's take a look. Looks like here. You see it forming?
Yeah, the black.
It's a black coating. Yeah. So this one, clearly, the reaction is very fast. The black coating is silver metal. Tiny, tiny crystals of silver. As they grow bigger, it'll have the proper silver color. They'll turn more gray as the crystals grow big. Tiny crystals look black because of the way they interact with light. Yeah, it looks like mold. Exactly, black mold. Fuzz. But pretty soon it'll look like silver. If we get big enough crystals. Okay, what's next?
That's it.
Except we didn't do we do part
No, we didn't do part
B?
No.
Okay, part B, we don't have to do that many reactions for part B. Iron 2 sulfate and silver nitrate. Let's do that one. Iron 2 sulfate is a light green,
Yeah.
although this is pretty weak. Let's see what happens. Silver nitrate is a CCS. So what did you predict? You predicted a precipitate of silver sulfate? Is that what you predicted?
Yes.
Silver sulfate's white.
Yes.
Sulfate's colorless and silver ions are colorless. So let's see what we get here. So I put in my iron 2 sulfate here, and actually silver nitrate. Let's go. Do you see? I see a white precipitate forming. Maybe. Yeah. A precipitate. Looks like I got a white precipitate. But the white precipitate is starting to darken in color. It's starting to turn. Yeah, well, let's see. Sorry. I'm going to bring this around one more time. It started off as like a pretty bright white precipitate. Okay, now I'm going to let it react longer. It's not green, it's starting to turn. Actually, it's starting to turn black. They're small black particles. It's hard to see. But it's starting to turn little black particles as they forming back. Let me tell you. I'm sorry? Well, it used to be a bright white. Now it's not a white mixed with black. It used to be a bright white solid. Now it's kind of a black solid mixed with a white solid, and the white solid's starting to be less and less prevalent. And so let me tell you what's happening. What's happening is there's a redox reaction, and that black, those are crystals of silver metal forming. So crystals of silver metal are forming. All right, what's the next reaction? Okay. So potassium dichromate, I'm gonna, it's in this bottle here, so you can't really see the color. But a lot of people say potassium dichromate looks like grape juice. Do you see it?
Yeah.
Looks like phenolphthalein or maybe grape juice or something. You don't want to get it on your fingers because dichromate's a pretty good oxidizer. And then some sulfuric acid and some oxalic acid. So let me get the oxalic acid, because potassium dichromate needs what to react? And so this is just potassium dichromate here with oxalic acid. Let's see what happens. Oxalic acid solution is a CCS. Oxalic acid molecules are colorless. So I guess I'm blocking this here. Can you see what's happening? Yeah, it's because nothing really is happening. I'm missing a key ingredient. What ingredient am I missing? For dichromate to do its oxidizing, it needs some H+, some acid. And so now I'm going to add that. You know, it's like nitrate. Nitrate needs that. H+. So let's see what's happening here. Nothing's happening. Sorry. Nothing's happening because I added the wrong stuff. Let me just do this one, and then we'll do the rest later. Finish this one. Sorry. So I'm going to take my potassium. Is it? Oh, no wonder I'm doing the wrong one. Sorry. Doing potassium permanganate. I need to do potassium dichromate. Potassium permanganate is the purple one. Potassium dichromate is like this. You see potassium dichromate?
Oh, yeah.
It's orange. I want to be careful with this because this has chromium in the what charge state? Not 7. Yeah, this is the famous chromium 6. Aaron Brockovich. Okay, now I'm going to add oxalic acid. I'm sorry, I grabbed the wrong bottle of both reagents. So that's the dichromate. And then I'm going to add some oxalic acid to this. And let's see if I get much reaction to occur. Actually, I am starting to get reaction to occur. Well, I don't know. Maybe it just got lighter. Do you see? Well, maybe
It's a little darker.
it's a little darker, so something's happening. But what ingredient am I missing? I'm missing the
H plus.
H plus. So let's add some H plus to this and then see what happens. Oxalic acid does have H plus.
So it couldn't, but is that why it turns a little bit? Because of that?
Yeah, it turns a little bit but oxalic acid is a weak acid, whereas sulfuric acid is a strong acid. So we're going to get more H plus this way. And so you're right, we don't really need to add the sulfuric acid. It'll just react faster if we add the sulfuric acid. Yeah, it's turning burnt orange, but you know, we should be able to see bubbles of gas forming. But it's happening very slow. I see the bubbles of gas.
Is that CO2?
It's CO2. Let me add some more oxalic acid to this. We can get it. But I'll just make a run through here. Just look on the inside walls.
Oh, yeah, I see.
Oh yeah, CO2. That's not a very spectacular reaction because is oxalic acid a very good reducer?
No.
But it's being oxidized. All right, we're out of time, so what I'm going to do is I'll just finish these up next time.